In this video, we're going to look at how to solve the absolute value equation. Absolute 2x minus 1 is equal to x plus 1. To begin with, we need to understand what is an absolute value function. You often see the absolute value function written as f of x is equal to x in between the two vertical lines. These two vertical lines is called the absolute value function, or sometimes known as the modulus function. And we define this as being equal to x itself when x is greater than or equal to 0, and it is defined to be equal to the negative of x when x is less than 0. So by this definition, this means that the output from your absolute value function is always going to be positive. In other words, the absolute value function gives us the magnitude but without the direction. In other words, no sign. So let's look at some examples. My first example, I've got the absolute of 5. Since 5 is positive, it is simply just going to be equal to 5. And that is essentially the distance between 0 and 5. The second example, we've got the absolute of negative 5. Since negative 5 is negative, it's going to be equal to the negative of negative 5, which is also a positive 5. That's the distance between negative 5 and 0. Note I use the word distance, meaning that it's got no direction. The third example, we've got the absolute of a minus 1. This will be equal to a minus 1 if a minus 1 is greater than or equal to 0, or if a is greater than or equal to 1. And it would be equal to the negative of a minus 1 if a minus 1 is less than 0, or a is less than 1. So now that we understand what an absolute value function does, let's proceed to solving our equation. So we're going to solve the equation. The absolute of 2x minus 1 is equal to x plus 1. Using the fact that whatever is inside the absolute value can be either positive or negative, there are two possibilities to this equation. First, we need to consider the case when it's positive, in which case 2x minus 1 just remains as 2x minus 1. In the case where 2x minus 1 is negative, we need to rewrite it as the negative of 2x minus 1 to make it positive. In the case where 2x minus 1 is positive, we're going to be solving the equation 2x minus 1 is equal to x plus 1. So I'm going to begin by adding 1 to both the left and the right hand side. This cancels out the negative 1 on the left, and this is going to give us 2x is equal to x plus 2. I'm then going to subtract x from both sides. That cancels out the x on the right, and I'm going to get x is equal to 2. And x is equal to 2 at this stage is only a possible solution, and you'll see why later. Next, we're going to look at the negative possibility. If 2x minus 1 is negative, we're going to be solving the equation negative 2x plus 1 is equal to x plus 1. So I'm going to first subtract 1 from both sides, and this happens to cancel out the 1 on both the left and the right hand side. Then I'm going to subtract x from both sides as well. This cancels out the x on the right, giving us negative 3x is equal to 0. Then dividing both sides by negative 3, we're going to get x is equal to 0. So again, we have x is equal to 0 is another possible solution. After we have solved for x, we also need to test whether both solutions are valid, because it's not always the case that both solutions are valid. So we're going to begin by testing our first solution, x is equal to 2. So we have got the equation. We're going to sub x is equal to 2 into the left-hand side. So we're going to get the absolute of 2 times 2 minus 1, or the absolute of 4 minus 1, or the absolute of 3. And this is simply equal to 3. On our right-hand side, we're also going to sub x is equal to 2 into x plus 1 as well. So our right-hand side, we have 2 plus 1, which is equal to 3. So we've got the left and the right-hand side being the same, which is equal to 3. So we can conclude that x is equal to 2 is a solution. We're also going to test the other solution, x is equal to 0. We begin with the equation again. we're going to sub x is equal to 0 into the left-hand side. This is going to be the absolute of 2 times 0 minus 1, which is equal to the absolute of -1, which is simply just 1. For the right-hand side, we're also going to sub x is equal to 0 into it. So we're going to get 0 plus 1, which is 1. So both the left and the right-hand side are the same again, which is equal to 1. So we've got left-hand side is equal to right-hand side. So we can conclude that x is equal to 0 is a solution. So for this equation, we have got two solutions, x is equal to 0 and x is equal to 2. Let's now try to understand why we get two solutions when we solve this absolute value equation. First, we're going to look at the graph of y is equal to 2x minus 1. This is a straight line graph with y-intercept at -1 and gradient of 2. When we take the absolute value of this function, the section of the graph that is above the x-axis stays the same because it's already positive, but the section of the graph that is below the x-axis gets reflected about the x-axis. The negative section now becomes positive, and together this V-shaped graph is the graph of y is equal to absolute 2x minus 1. Then when we have the graph of y is equal to x plus 1, which is a straight line graph with y-intercept at 1 and gradient of 1, these two graphs intersect at 2 points, when x is 2 and when x is equal to 0. And in fact, these points of intersection, the x values, is what provides us with the solutions when we solve this equation. Thanks everyone for watching the video. I hope you guys found that useful. In our next video, we're going to look at another example where we have to reject one of the solutions in the equation. So hope to see you all there. Bye for now.